And welcome to the ground cover session for today's AI Deployment Summit, where we'll learn why in the AI era, traditional observability solutions are breaking down, and how an AI optimized bring your own cloud solution is helping teams regain deep visibility and complete control. Our speaker this morning is Adam Hicks, Senior Solutions Architect at GroundCover, and he brings us a very timely session, Observability Isn't SaaS, It's Yours, where we'll learn how Bring Your Own Cloud is driving a new level of AI observability. Adam, welcome.
All right, thank you, Vance.
Totally our pleasure to have Adam with us this morning. Throughout his career, Adam Hicks has specialized in solutions that deliver deep visibility into enterprise architectures, and he now expands that focus to AI workloads. At GroundCover, Adam is bringing observability and AI workloads into a unified, easy-to-operate platform. In today's session, we'll learn several great takeaways, how and why traditional observability tools are now under stress, where AI builders struggle with blind spots, code spikes, and compliance risks, the architecture and benefits of GroundCover's AI optimized bring your own cloud solution, and we're going to get a couple of great view screens of how GroundCover works to bring AI observability and control to your projects. So great session. Just a quick reminder before we begin, you can download today's slides. Just click the big red button on the view area. You'll also see some other great downloads and access to resources to help you in your discovery of GroundCover, all available just one click away in the links below the view screen. And we love your input. So to ask a question, connect with Adam, just type in the submit a question box. So Adam, with that, let us hear from you and tell us about how observability isn't SaaS, it's yours.
Awesome. Thanks again, Vance. And I want to start off with a premise that observability data is really about the data, and AI observability data is really about the data. And to that end, observability shouldn't be about software as a service. This is a fundamental shift, I think, from the vendor ecosystem that most of our customers are familiar with. We don't believe that you should be locked in by SaaS vendors. You should have the right to monitor everything and capture as much data as you need at a fair price while keeping it private and secure inside of your own cloud. So that's what I'm going to go over today. Let's start with a little bit of perspective on the landscape. I'll call them legacy observability tools, and the SaaS platforms that have evolved from them were fundamentally built for a different era of IT monitoring. While they certainly played their part in how observability has transformed through time, honestly, today, they're struggling to keep up with today's cloud-native world. Modern applications, especially those that we have seen at the cutting edge, interacting with LLMs and building AI agents, they're generating terabytes, even petabytes sometimes, of telemetry data. This overwhelms traditional SaaS architectures frequently and creates oftentimes processing delays. Additionally, there's a per gigabyte pricing model that we've seen in place, volume-based financial models for observability platforms that become prohibitively expensive as data scales. Also, sensitive telemetry data crossing organizational boundaries raises compliance issues and regulatory challenges. And I'll revisit what I said before about modern applications with LLMs. We're now seeing AI use cases for organizations developing against LLMs where sensitive data is certainly a great concern, not just for say PCI data or PII data or HIPAA data that may cross boundaries and interact with LLMs, but also for data that is going to be used to train these models additionally. So what has ended up happening is that teams are now faced with growing complexity in their cloud native environments, and they have unpredictable costs. They don't have a way of handling that because it is volume based and they're on an accelerating curve. They also have siloed product lines frequently. So you create data silos for your observability data, your telemetry data, even though your applications aren't necessarily themselves siloed, or requests that you may see from users are not siloed. Then you have to make data budget trade-offs. This could include something like sampling. For the customers that are out there that have matured and started developing tracing, sampling is something that should be familiar to everybody. And there could be very good cause to do sampling. But if we could keep all of our telemetry data, I think all of us would agree in the industry that we would. But we have to make those trade-offs. What should we keep? Does that then create blind spots? Rate limiting is another challenge that we face. And none of these help us when we're trying to manage resilience, reliability, or even incorporate observability into how we develop our applications. One of the things that we've actually seen in response to this is a return to self-hosted open source. I'm a huge advocate for open source. We enable open source. We use a lot of open source ourselves in our platform. It comes with operational cost. So it's a double-edged sword either way you slice it. So we asked ourselves, what would a modern observability service look like today? First of all, we recognize everything that I was saying before when I was laying this out is that it's fundamentally a data problem. It's a data management at volume problem. It's a data structure problem. And it's a data movement problem. And it's a data cost problem. Well, the main problem with the SaaS model is that it really does fragment your stack. And it doesn't necessarily have to, but I would say that the way that it's been implemented from a lot of vendors, it certainly does. Logs live in one tool or one backend to a tool, traces in another, and metrics in a third. Then what ends up happening is that every time something breaks, engineers waste hours switching between dashboards or trying to correlate symptoms across tools that don't talk to each other. They lose context. During incidents, rate limits might kick in right when visibility matters most. And the kicker is that every gigabyte costs more as well. So observability should make debugging easier, not feel like debugging your observability tools. But I have seen teams that frequently conflate site reliability engineers with tool maintainers for their observability tool stack. So they have an SRE team for their SRE tool set instead of an SRE team for building reliability and resilience into their applications. So we started rethinking this, and especially when we think about AI agents interacting with LLM data, this becomes all really important because most of the time they are cloud native. We wanted our tool to also be cloud native. OC native, bring your own cloud. And we'll talk a little bit more about what that means in a second in the context of ground cover, and especially how that matters for AI data. And that we also needed to be able to work with the tools that customers are used to. We wanted to go towards host-based pricing, not data-based. So it doesn't matter the volume. It matters what it is you're actually monitoring. We wanted to do away with cardinality limits or retention limits, or at least make it easy for you to understand the impact and keep data where it matters the most. Cardinality specifically is one I like to talk about as being your observability oil. It's the gold for your systems. Where you have high cardinality, frequently it's because you have a very unique dimension that you need to understand. And it can bring deeper insight sometimes than other data. Why shouldn't you be able to keep that? Why should you be penalized for it? We also wanted to focus on the developer and make it easy to interact with, whether it's deploying or instrumenting your environment. And we also wanted to work with new observability signals, whether those are trace-based, event-based, metrics-based, logs-based, LLM-based, and get across them all. This means that we can move into what I'll call a best of both worlds type of model. This is what we call BYOC, bring your own cloud freedom. It helps us keep your data inside of your, and I'm going to use a very specific AWS nomenclature here, but your VPC, but your network. we deploy into your hyperscaler environment or even into an on-premises environment. We have a managed experience, so you get the operational ease of it being SaaS, but you have the privacy and control of on-prem. I told you that we would talk about how this is relevant to AI data, but hopefully, if you're following along, you're already seeing that and thinking about that, because if you have sensitive data interacting with LLMs, then it makes the most sense to be able to keep that data inside of your four walls. We see our customers deploy this in all different environments, large financial institutions with strict compliance to fast-moving startups in EKS, same performance, same cost advantage. And because we don't sample by default, you can actually afford to store all of your telemetry. And that's what makes modern debugging possible. It keeps that high fidelity that allows you to troubleshoot and understand what customers are doing. Another unique aspect of us is an investment that we've made in eBPF. We are able to accept in data of all forms, trace data from OpenTelemetry instrumented systems, metrics data, in a Prometheus format, logs, be it structured or unstructured, you can send in. But for your Linux-based hosts, for your Kubernetes clusters, for these modern environments, we also have an eBPF-based sensor. Extended Berkeley packet filter. For a lot of our customers, Kubernetes has become their de facto cloud. This is their environment for their cloud native workloads. We give a Helm chart over, it deploys in minutes. You're able to install the eBPF sensor and the environment that comes with it. It pushes data into a dedicated backend. Your front end is accessed from our cloud. It's the only part that's hosted, giving you that SaaS-like model. And you can get instant zero implementation visibility. No SDKs, no code changes, no requesting your development teams to instrument. Traces, metrics, logs, all automatically correlated. Oh, it hooks at the kernel layer, meaning that it sees every request, every trace, every event without touching your application code. In practice, this means that you get full visibility from day one across every microservice and now every LLM call. What you get is a single pane of glass unifying infrastructure, application performance, real user monitoring, and now LLM observability. No add-ons, no enterprise tiers, no AI monitoring SKU. We have one SKU and it's all built in. So when we talk about 10 times more data for a fraction of the cost, this is what enables it. One unified system instead of 5 disconnected ones. Now let's talk about why this matters so much for AI. I've been peppering it in already, but I want to focus on this for just a second. LLM applications are fundamentally different from traditional software. They're probabilistic, they're multi-step, and they're dynamic. You can't just log a single request and call it a day. Latency balloons across agent chains, prompt drift and hallucinations silently degrade quality, all things that we've seen. And of course, sensitive data, we've talked about this in preceding slides, but it flows through the prompts every second, oftentimes in ways that compliance teams can't even see. Without specialized observability, you lose the base understanding of where time, tokens, or risk are trending. So this is a huge blind spot in AI, and of course, where we step in to help with our LLM observability feature set. So what exactly is it? It is the practice of monitoring and analyzing how large language models behave in production as we interact with them. So just like you might observe an application, but with entirely new dimensions, to be frank. So we collect all sorts of telemetry on these completions, latency, token usage. I'll show a little bit of this in a minute, but it allows us to help you find patterns, which models perform best, which prompts degrade, and where costs or errors spike. So the goal isn't just visualization for our customers, it's being able to incorporate this so that they can make continuous improvement. So think of modern observability, and this is not just specific to LLMs, of course, but modern observability allows you to create a new feedback loop: collect, analyze, optimize. So this loop is how AI applications are becoming reliable, cost efficient, and production ready as well. In this slide, you have some visualization from our product. We have a map, which helps us contextualize how these applications are consuming AI services, specifically in this one, Anthropic, as well as OpenAI. And then another one showing how we can start giving you a lot of rich data across traces or telemetry, really, for a service that is interacting with these LLMs on the back end. So we've taken the classic pillars of observability: metrics, logs, and traces, and we've simply extended them for the AI era. So first, prompts and feedback. These are the heart of LLM apps, and logging them lets you identify drift, template failures, and quality degradation. So second is tracing, and we follow every step from prompt assembly to retrieval to output parsing. So you know exactly where latency or errors are appearing. Third, latency and usage. We want to know. LLMs are expensive and they're slow, so tracking things like token usage or the time to first token, output tokens per second, these are some key metrics that you might see. Model version and response time start giving you direct cost control. It's not even just about performance. It can also be about the expense. And then finally, retrieval analysis. So for things like RAG, retrieval augmented generation, we measure speed, cost, and soon relevance, which is the next frontier of AI observability. So here's how it looks inside a ground cover. We capture every LLM request and response. This is in the preceding visualization. I showed you overall span analytics or trace analytics. This is looking inside of a single span. We drilled in. We get the LLM request and response, the full payload, token counts, latency, error patterns, all automatically. I didn't have to instrument anything. While we certainly could take in data from code level instrumentation, this eBPF sensor enables this to happen transparently at the kernel level automatically. So no proxy, no SDK, no wrapping your code. What this means then is that you can debug a failing LLM output with the same depth that you are able to debug a 500 error or 404 error. Full context, full fidelity, zero friction. Once you have this visibility, you immediately are able to gain control over one of the hardest problems of AI operations, and that is cost. We mentioned it before, but it certainly is an emerging area of growing concern. Token usage frequently varies wildly across services, routes, even model versions. When you can actually see that data, you can optimize intelligently. So maybe you don't need GPT-4 or for a simple classification task. You could use machine learning instead of using an LLM. These are great examples. On top of that, we help teams monitor latency trends, error patterns, model performance, because you have the fundamental building blocks of the application's interaction with the LLM at your disposal across metrics, traces, and logs. You can slice and dice and review this in any way that you need to answer the questions that you have. At the end of the day, when engineers can correlate performance and spin directly, they're able to make better design decisions. And that's what matters. And that can often cut AI bills by 30% or more. The magic moment for most teams is when they can go jump into a single LLM trace and evaluate what's going on. This allows them to see the entire journey: which model was called, what retrieval happened, how long the tool call took, where a misconfiguration occurred. This is an example here that you have open the response payload, but on the main part of the screen, you have an error. Might be another experience that somebody has. GPT too large does not exist. Immediately traceable type of activity to a specific service. So no guesswork, no log digging, no SDK stack trace. And this is how debugging AI becomes as easy as debugging a web request. In one of these screenshots, you can actually see how we're also able to overlay this trace with system context, something that we do that no other observability tool I've ever seen, and I've been doing this a long time, does out of the box like we do. We can put trace, logs, events, all in context with system level resources, container level resources. And this can be compute utilization, but also network utilization and even storage performance for cloud native workloads that have persistent volumes. I want to go back to the BYOC and why this is so important in the AI era. And this is because of security. There's more, but it is a non-negotiable in the AI era, as I've harped on in preceding sections. Every LLM prompt can contain sensitive data, customer information, PII, intellectual property. With Bring Your Own Cloud, all that telemetry data stays within your VPC. None of it is ever copied to ground covers infrastructure. That's how you get observability and compliance in the same sentence, something that's usually impossible with SDK or proxy-based tools. The architecture difference isn't subtle. It's everything. Where others require SDKs, we use eBPF. Where they ship your data to their cloud, we stay in yours. We don't gate features or throttle visibility. You get 100% capture, flat pricing, and a single platform that handles infra, app, and AI together. This isn't about feature parity. It's a structural advantage. And it's why we can say with confidence no one else can deliver this level of visibility without trade-offs. When something goes wrong with an LLM workflow, latency spikes, errors, what's the cause? Is it the model provider, a database bottleneck, or network congestion? With siloed tools, you're guessing. With ground cover, you see it instantly. We correlate LLM metrics with infrastructure and application data automatically. It means faster mean time to resolution, clear ownership, no finger pointing between ML, DevOps, or platform teams. The reason that we have seen teams adopt ground cover isn't just performance, it's peace of mind. They get this complete visibility, the ability to deploy in minutes, and they never, ever have to worry about hidden quotas or rising bills. As workloads grow, especially AI, they know exactly what's happening, where it's happening, and how much it's costing. We have a saying here that with ground cover, the cost of observability grows sublinearly. With other vendors, I have seen logarithmic or exponential growth in observability costs as their application complexity grows, their infrastructure grows. Many of our customers are also SaaS providers. So as they're growing, it makes sense their observability costs would grow. But why should they grow faster than their own infrastructure? With us, it's the opposite. As you grow, we benefit from the economies of scale by being inside of your own cloud, and we're going to grow sublinearly. What this results then is that we scale without limits. We have elastic pipelines for you at your disposal, infinite retention, high cardinality that ensures that your observability grows with your stacks instead of against them. Blazing performance and visibility too. eBPF sensors capturing every signal in real time, delivering full fidelity telemetry and instant queries, including LLM calls. Cost efficiency with clarity, predictable per node pricing, compression and object store offload, and zero egress and ingestion fees help us keep costs low for you and transparent. We're private and compliant. That means that data stays in your cloud with enterprise-grade security, SaaS simplicity, and no add-on tiers. Little snippet of something our customers might say. Similar web has eliminated Datadog's integration overhead, and they were able to gain full stack visibility with zero code changes. Platform teams now deploy LLM monitoring in an afternoon, not in a quarter. And for industries like finance, BYOC isn't a nice to have. It's the only way they can even use AI safely. These aren't just marketing slides, by the way. These are real voices of engineers and platform leads in production. They talk about something deeper than features, and that's trust. Trust that data stays private, costs are predictable, and the platform will actually scale with them, not against them. Final piece. Getting started is super easy. Deploy ground cover with a single Helm chart. Within minutes, our eBPF sensor starts capturing telemetry. No config, no SDK, no restarts. You get to go from zero to full stack observability, including AI workloads, before your coffee even gets cold. That's what zero friction really means to us. Every ground cover customer now gets full LLM observability automatically. No code changes, no quotas, no data leaving their cloud. The way we see it, observability isn't just about knowing what's happening. It's about taking ownership of your data, your performance, and your security. And in the age of AI, that ownership is more important than ever. So I really appreciate you taking time listening to this and paying attention. And I'd love the opportunity to show you how this looks live. So reach out, let me know. So this concludes my presentation for today. I'm going to turn it back to Vance and see if there's any final remarks.
Adam, great overview, great instruction on the need to modernize my observability platform for these new AI and LLM requirements, and certainly how to deal with that massive extension of telemetry data that's out there. Really great session. Thank you.
Thank you very much, Vance.
Excellent, excellent. Thank you. Yeah, Adam, it's really great to have you here. And you mentioned questions. Luckily, we have a very curious and intelligent audience with us this morning, so we've got a few. So with your permission, let's go right to questions.
Yeah, sounds great. Let's do it.
Excellent, Adam, excellent. So let's start off with a baseline. And so here we've got a question and a comment. We're familiar with OpenTelemetry-based tools. How does ground cover differ and offer better support, perhaps, for AI agents and LLMs?
Yeah, that's a great question, Vance. Thank you. For starters, we actually are completely compliant with OpenTelemetry-based data. Our eBPF sensor is what I might call secret sauce in terms of turnkey understanding AI agent interaction with an LLM or application interaction with an LLM, being able to go get those metrics in terms of token usage and the experience and give you feedback on hallucination without having to do anything else. But if you've already gone down the path of instrumenting your applications with OpenTelemetry and you want to send those in, you get the same experience as well. And in fact, you can send your data through our eBPF sensor and get more. So if you have started maturing your OTel journey, but have yet to tweak and tune it, and this could be anything from logs correlation to LLM chat experience capture to metrics contextualization, sending it through our sensor will do all of those for you. So we are actually a great partner for your OTel journey.
Oh, that's awesome. That's awesome. Let's go one level deeper here, Adam. I know we didn't have time for a full demo, so this seemed like a pretty appropriate question. Can the speaker summarize what does the user actually see?
Yeah, so the user has LLM interaction data in various different places inside of the application. So I would say that ground cover has a purpose-built heuristic workflow for helping people ask questions about their applications and get answers. And this could be coming in because of an incident, a monitor that's firing, or an alert that they received from a monitor firing, integrating into a chat system or incident management system, and they can drill in and find out how all of the different signals, including those that are interacting with LLMs, are being affected. It could be query interfaces where they can just ask questions and analyze trace data. It could be dashboards that they want to go build to, I'll say, like dimensionally slice and dice metrics, trace, or logs data across them all.
That's really interesting. I'm glad we asked that. So, a quick thing there, Adam. So, in addition to getting very visually appealing and discernible dashboards, I can actually interrogate my data for those that are perhaps new to this whole thing and have it not just give me a data response, but tell me what that means in context of my project.
Yeah, absolutely. And to tip my hat on something that I hope we get to talk to you and your crowd about at a later date, we also have an MCP server that we run. So you can bring your operational AI agents, plug those in, and even query the data using your own AI.
Adam, time is just flying by, but this is really awesome. Let's turn to a broader vision here. I think you mentioned this before, but just to underscore it, the question here says, does ground cover handle the full life cycle of observability data for AI? And if so, please walk us through ground cover's vision of a life cycle.
So when we talk about full life cycle, I want to understand how, say, an agent or an application interacting with an LLM is doing so. I want to see the initiation of the request. I want to see what happened and what can be surfaced from the LLM back. And that's where you get token usage, the chat experience, any sort of error codes that may be surfaced from the LLM as well, just like it could be from any sort of application service. Something that comes up quite a bit in the observability or monitoring world would be this notion of, I'll call it a black box service. It will say, oh, I'm using a SaaS service, and it's somewhat of a black box. Those black boxes do give you information, telemetry data about behavior of the request as it traversed that system. And it's the same thing with an LLM. So when I think full life cycle, I want to understand everything that I can interacting with that LLM, that black box, as well as anything that LLM will give me access to as a service. So any metrics that they'll give me back as feedback, response code is a perfect example of that.
Perfect. As time expires, Adam, let's squeeze this in. Not only do we talk a lot about the technology enablement of support ecosystem, let's call it, for AI and LLM, but we also like to talk about the career opportunities, the user skills, upskilling. And you talked a bit at the start about siloed developers. And the question here says, in early use cases, does ground cover see any virtuous cycle where extended teams begin to participate? In other words, who should be in my AI team, and does ground cover offer data that would let us extend that team?
So that's a really interesting question. I am a believer that a hallmark of a very high maturity organization is that they have democratized access to observability data. Observability data should not just be the remit of operations or infrastructure who are in that hard world of uptime. I think there was a time in the industry's history where that was the case, but we should allow everybody from all walks to interact with the data and ask questions that are relevant to their point of view within the business. And we've created, I think, a pretty revolutionary data access model as well. One of the problems with observability data could also be, not just compliance that it's running in somebody else's cloud, but also compliance inside of you as a customer who can see what and has access to what. So not only do we have ways to do sensitive data obfuscation as traces or log data comes into the ground cover system, but we give you an RBAC model that tightly scopes who can see what across your environments. And I say it in plural because you have the ability to run multiple ground covers to serve multiple different needs because of this BYOC architecture. And that means that you don't have to gatekeep observability, and you can, like I said, democratize observability data for all. So different people in different silos can now see what's going on across those boundaries and understand how changes that they're making are creating an effect on different elements or aspects of the system.
Really excellent. And it looks like time is expiring here now, Adam. So thank you very much. But before you go, talk a little bit about how we can learn more about ground cover, and particularly how folks who might be used to a SaaS solution can begin to implement it. Sometimes when people hear the phrase open source or they're bringing their own cloud, there's this little cloud in their own head that makes it seem like it might be complicated. So walk us through some of the ease of use features you've got and how people can maybe take a test drive.
Yeah. Number one, schedule a demo. We'd love to talk. This is something we do all the time. But number two, setting up ground cover, whether it's an enterprise trial or it's running our free tier, is super simple. It is just a Helm chart if you're running our free tier. If you want to set up a trial for our managed backend, reach out to us as something we can set up in minutes and help you understand. And as I said, it really is just a Helm chart. That's it. We give it to you, you run it on a system you want observability on, and we're off to the races. We don't want to be the big bad boogeyman with, heavy duty POCs. So if you have a use case and you want to talk, we'll help you set it up and try it out. And it takes very little time at all.
Awesome. Awesome. Adam Hicks, Senior Solutions Architect at Ground Cover. Thanks very much for a great look at Ground Cover, a new level of observability and control and visibility for our AI and LLM projects. And I think you have alerted some really interesting possibilities in the minds of our attendees. I could tell that the questions were really excellent. So attendees, thank you for really helping us peel the layers of Ground Cover. Adam, thanks again for coming.
Thank you.
And a quick note to our attendees, here is a list of links that will take you to even more deeper resources. And to get this list, all you have to do is download Adam's slide deck, available to you with that big red button. Just click that and you'll get a copy of these slides. And this particular slide with the links will be in that deck. So thanks again, everyone.